Hi guys, welcome to Learn Electronics Repair. I have some headsets here, Bluetooth headsets. These are from a local call centre, a marketing company. We seem to have quite a few of these sort of companies here. I think it's probably because internet is cheap here and very fast. We have very good broadband here, fibre optic, and also wages on the Canary Islands are considerably less than mainland Europe. We kind of have a European infrastructure here with an African type economy really, so I think that's why. So this particular call centre deals basically with Scandinavian clients. It's all Scandinavian. So you imagine they have a lot of people using these. I have 4 of them here, and these fail. I mean, they tell me these are like about €300 each, but I look online, they're more like 200 or a bit less, but maybe it costs them more when they get them shipped over. And the problem with all of them is that the microphone stops working. So this time I have 4 of them. Let's have a look to see what the problem is. I mean, this could be a software problem, a Bluetooth problem, a driver problem, but to be quite honest, because you have so many of these in the call center, you can be assured when they give you some faulty ones to repair, they are faulty, because it's easy for them just to try. Yeah, they know how to use them, they know how to have the drivers loaded, so they have many machines. They can just, you know, they have a working set, they can try one of these, so we can be certain enough these are actually faulty and get on with actually fixing them. So to get inside them, we need to undo this little screw down here. That one. Okay, so I have the right one. This is, well, it's a T5. Probably see it now. Okay, it's that one. So first we remove the screw, okay, and then you have to effectively get this apart, and it's held on with like a little clip at the other end, so you kind of have to like just angle it right to get at it. Don't put too much strain on it. Okay, so it is off. They're just fiddly, that's all. You can see these are the speaker wires. Now this one doesn't look too clever. These are too close together for my liking, but what I would normally do with this is to put a bit of epoxy resin just there, just to stop them from touching each other. It's the only thing you can really do with them. So we need to get to the other side of here. This is where the microphone attaches. So to do this, we need to take the other side off, which means we have to undo these screws. The ones we want are like the inner ones, so that one, and this one. Okay, and there we come. Cover comes off now. And you can see here, this is where the microphone comes in, and you can see where it's damaged, where it goes through there. Okay, that's where they fail normally. So to get to that, we have to take this plastic cover off. This is effectively held on with clips, so we need a spudger. These 4 bolts here actually just go into the PCB. I can just show you. If I take one out, you'll see they don't actually hold this plastic piece in at all. Okay, I mean, I've unscrewed it so far, but I think you can clearly see they don't hold that plastic piece on. But what does hold this on is some sticky tape underneath it. Okay, so the tape go there. Okay. You might find, as I did, as this little clip comes off while you're taking that plastic piece off, it actually just pushes back on over here. If you have a look, you can actually see the shape of the slot, so you have to get into the right position to slide it over here. And that's what was causing the problem with the other end, by the way. When you actually took the speaker out, you have to find the right place. Okay, so that gives you an idea what was going on. Now, the problem is to fix this, so we know it's broken where it comes through here. Okay, we can see the damage there. So we're going to have to cut this off here and then effectively extend it. There's no other way to do that really, or at least that I can think of. Okay, you can see where it's gone there. It's held in with a little bit of glue on this one, sometimes they're not. So we can push the glue out from here. Okay. There you go. We now have the other end of the wire, so you can see what the problem was with it. It's there coming through. Okay. So I'm going to cut this off and then we'll have to extend it, as I mentioned. There you go. We'll pull that back through this side. Okay, there's our bad wire. This is held on with like glue. You can try warming it up with hot air if you like, but it's fairly flexible, I think, really. Okay, we need to clean the glue off, so let's see if we can do it with tweezers. Yeah, see? There we go. Okay. And the same with this end where it's soldered. These tweezers are a little bit thicker, so see if that makes it any easier. Yeah, possibly. I think at this point I can probably unsolder these and then the rest of the glue should come off quite easily. In fact, actually guys, I can clearly see the solder pads now, so I'm not really worried about that bit of glue that's still on there. It's not going to cause me a problem anymore. What I will do is just add a bit of fresh leaded solder and clean these up. Okay. So they're ready to accept the extended little bit of coax I'm going to have to fit on that. So I need to get a little bit of coax down through the hole. And then we need to attach it to this. So let's strip this back and let's see how much good we have. I mean, the inner part there is actually okay. You can see it was the outer braid that broke. So if I strip this a little bit further, I can effectively leave this piece in. That's what I'm thinking. I can tin this. I think I have it. If I add a little bit of flux to that and just a bit of solder, we'll soon see what happens. So a bit of flux on there. A little bit of fresh solder. Okay. What happens? Well, it tins, yeah, you can see it's tinned nicely. I'm just having a look at this and you can see this isn't good, so although I've tinned the end of it, it's obviously gone there. So I need to strip this back a little bit further. Okay, and then separate the braid from the inner wire, the conductor in the middle there. Okay, so just do this with my fingers, it seems the easiest way to do it. Okay, pull that apart a little bit. So let's cut this off here. Now let's see what we have. As you can see, guys, this is extremely fiddly, so I'm going to do this under the microscope where we have stereo vision. Now I have a much better view of what's going on. Trying to keep this in shot for you guys won't be easy, but I'll sort the wires out. Okay, again, I'll see if I can tin the inner conductor. This sort of wire is not particularly easy to work on, as you can see. Okay. Yep, it's tinned. And we'll try to get this one as well. That'll want some flux. Okay. Yeah, you can see they're both tinned. So if we measure the resistance between these two, we should see something that isn't a short, and I wouldn't thought it be open either because we should see the microphone. No, it's about 1.1k. So that seems much more reasonable for the microphone. Okay, so what we need to do now is effectively extend these enough so we can get them through to the connection on the other side. The problem I have, I need to get two wires down through this little hole, even it's tiny. So I also need some way to attach this to the other wires, and I think the way, there's a bit of Vero board. If I stick it on top of here, I can solder these two wires to the Vero board. I can check then that the microphone will actually rotate and I have the correct resistance, and if I have, from the Vero board I can solder two more bits of wire down through the hole. It'd be nice to have a bit of screened wire, something off maybe a scrap set of headphones or something, but you know, considering the wire is not very long and the impedance of This microphone is about 1 kilo ohm, so it's not a very high impedance source. I don't think it would make any real difference to the audio quality. I don't think it would pick a lot of hum up. So let's see if we can stick a little bit of strip board to that. At least this way, this will all be anchored down. So I'll cut this in half, so I effectively have 2 strips. Okay, something like this I think will do just fine. Yeah, I don't need the strips to be whole. I don't need to actually solder through the holes. I just need somewhere where I can attach the wires coming from the microphone and then attach 2 more wires to go down through that one. Okay, I think the best thing to attach this with is going to be a bit of hot snot. Okay, so let's just take our bit of Vero board, dip it into a bit of this hot snot and then just apply it to the chip, and hopefully this will be fine. Always get stringy bits of this, of course. Stick that on there, and I'll just make sure that this fits into place properly. I haven't blocked over any of the holes where this goes, but they are further out, so that's not a problem, I think. Okay, so let's see. This goes this way round with the Jabra symbol that way. Okay, yeah, that's going to fit in just fine. So we can solder the wires onto here. Okay, doesn't really matter which way round I put it, as long as I get the wires the correct way round on the PCB. Even that probably isn't quite so important, but I will put them the right way round. Okay, let's see. I think we put the thing this way, obviously the red wire further in. I think that's the way to go. Okay. So that one onto there. Probably better if I just get a little bit of heat shrink just to cover over any stray wires here. Yeah, that looks good. Okay. Right. Without doubt, optical microscope is the way to do this as well. Fiddly stuff.
No, you know, don't say. Whew.
I do say. However,
can I help with that? Do you need a third hand?
No, there's not even enough room to get bloody 2 on there.
Yeah, you're right.
Just tag that on there, I can cut that bit off.
Ooh.
Trouble is to get us to take the solder without like getting another bit wide too hot and melting the sleeving. It's not working. Doesn't like the solder very much, this stuff. Bit more flux.
That's a pain in the butt.
It'll go. I'll have it.
Yeah, I know you will. I know you will. Mr. Magic Hands.
I think I do have it.
No?
No.
No, it doesn't.
No, now I have it.
Now you have it.
It's on there.
It's on?
It's on.
Great job.
It is on. Cheers. Yeah. So that's attached. I'll just measure the resistance across this and see if I see the 1 kilo ohm or thereabouts. Oh, meter's working. Okay, let's have a look. Yeah, about 0.9 of a case. That's about what it was before, so I'm happy with that. So all we really need to do now is attach 2 thin bits of wire from there through the hole and solder them under the end. And that should be fine. What I can just check is now if the actual microphone rotates correctly. Zoom out a little bit. Okay, so yeah, that's rotating fine through the whole range. I mean, obviously this will fail again. These things are kind of like designed to fail, I think, but should last a good while at least. I have some thin wire here. Detlef gave me this, actually, a whole reel of it, or they gave it to me, just suggested I use a bit of this wire wrapping wire. Okay, so let's see if we can solder this on. Because I don't have screened wire, I'm going to twist this together. This will probably help as well, a bit like a twisted pair type thing. Okay, unshielded, but I think there's actually help in noise reduction, anything like that. And if it doesn't help, I don't think it'll do any harm. Okay, comments. So I'll feed the wire through the hole. You can see now these actually fit quite nicely, or they will do. Yep. And then it's just going to be a matter of soldering these on. Again, I'll do it under the optical microscope. It's easier for me to work that way. Okay, so hopefully the other end will not unsolder or solder these on. Let's hope. Yeah, we can always hope. Okay, that's on. I just caught the plastic slightly there. I don't think it's going to cause a problem. Wasn't much room down inside there. A little spot of glue, probably just to keep it held down and stop this bit of wire moving. But because this is fixed static, I don't see that that would actually go anywhere anyway. Okay, and there we have it, soldered in position. So now it's just a matter of soldering the wires on the other side of the board. Okay guys, so that's soldered on as well. I'll just clean the flux off. I can put a little spot of glue on there, use a little bit of hot snot again. Let's just check if the resistance reads okay across here. And it does, just over 1k, same as before on the other end. I've also just fixed this one as well. You can see the wire effectively broke off from where it was on the board, so I've soldered a few wires onto that, extended that as well. Let's just get this plastic piece into place. Just before I do that, I'll reinsert this little clip. Goes with like the little recess for the screw to the outside. Okay. easiest to take that off first. There it is, it's on now. Okay, then this just clips back in place. There's like a little switch here which is activating, so I know that's okay. Yeah, it was click, that clicks into place. Switch is working. This moves, that's fine. Now I can put the screws in to reattach that side. And I just want to make sure that this doesn't catch up the wire on here. So effectively there's like a hole there where the peg goes in. So I'll just position this like so. Okay, and this now, yeah, that's moving fine, that's good. Finally we put this on so the little peg goes back into there, and then this, it's just a matter of turning the little clip around, sometimes pushing it upwards a little bit. Okay, you see in there what's rotating, like so. We get the hole to line up, we put the screw in. And we have it all back together, guys. So this thing, yeah, should move. Same with that one, yeah, it's moving. We have a free movement to the microphone. And normally speaking, that will fix these. That's what goes wrong with them. It's just, if you like, wear and tear, basically. No doubt in a few months or a year's time, they'll be back again. I have to fix them again. They have a lot of these and they do fail, you know, over a period of time. But they are what they are. It's the best thing I can say. Okay, so I'll take these all back to them. They have the software for these all set up on their computers. So that's the easiest way. They have the dongles that go with them as well. But from experience, I have fixed these before for the same company. These will be fine. This sort of work, if I do 4 of these, normally I charge them like €35 a time. That's 140 for doing 4 of them. If they replace them, it's going to cost them at least 800 to buy new ones. And the new ones will also fail in this way. It just seems to be built into them. So it's a kind of situation, it works for me and it works for them, yeah. Okay, hope you enjoyed that one, guys. And I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.